Let's face it, without the sun, we wouldn't be here. Its radiation is a huge part of what makes Earth's surface habitable to complex life, so we owe it a lot. But that radiation can also cause trouble, and I'm not just talking about sunburns. In a phenomenon called the solar wind, our star continuously throws out streams of charged particles at more than 500 kilometers per second. And while Earth's magnetic field protects us from most of that, the wind can also change dramatically. Those changes, at least near the Earth, are referred to as space weather, and just like regular weather can be a bit unpredictable and dangerous, space weather can be too. So last week, NASA announced 2 more missions to help us understand it. They won't launch for a few years, but once they do, they have the potential to teach us a lot. The first of these newcomers is PUNCH, which stands for Polarimeter to Unify the Corona and Heliosphere. It'll feature 4 suitcase-sized spacecraft in Earth orbit and will study how the corona generates the solar wind. It'll also study one of the biggest space weather events out there, coronal mass ejections, or CMEs. CMEs happen when large arcs of electrically charged particles and other solar matter erupt from the sun's surface. If they're oriented just right, or some might say just wrong, they hit the Earth. Although they're usually associated with solar flares, they're actually a different phenomenon, but they can still be a big problem. CMEs are powerful enough to wreak havoc on the electronics within Earth's satellites, and occasionally they can even make it all the way through Earth's protective magnetic field and damage systems on the ground, like power plants. Right now, it's hard to predict when CMEs will happen, so among other things, PUNCH will attempt to figure out how they develop. It'll also look for a way astronomers could forecast them, which would allow teams for both space and ground-based electronics to take precautions for their equipment before a space storm hits. To help with that forecasting, PUNCH will be the first mission to consistently track space weather in 3D, which, given that's what we live in, seems like an important step to take. Of course, the mission isn't scheduled to launch until 2022 at the earliest, so it'll be a while before we see results. But it's always good to know that NASA has exciting things in the pipeline. The second mission NASA announced last week has a less punchy acronym, but still pretty awesome. It's called TRACERS, and it'll launch with PUNCH, but it'll study how the solar wind affects Earth specifically. It's not pointed at the sun, but at us. The mission will be trained on the region around one of Earth's poles, where Earth's magnetic field guides charged particles coming from space down into our atmosphere. Usually, Earth's magnetic field redirects the solar wind around our planet, but sometimes when the Earth's and Sun's magnetic fields touch, the wind can push through in regions called cusps. It happens because Earth's magnetic field lines can suddenly snap and connect upon exposure to space weather. Similar magnetic reconnections happen on the sun itself, which is actually what causes solar flares and CMEs. But on Earth, it can send showers of charged particles toward us at nearly the speed of light. That causes the pretty light shows we call auroras, but it can also interfere with electronic equipment. So it's important to understand how these processes work. Together, PUNCH and TRACERS will help researchers on Earth, but that's not all. As a bonus, they'll also help future crewed missions to Mars, where astronauts won't have Earth's magnetic field to protect them. When those missions start, the more we know about the sun and space weather, the safer our astronauts will be. Meanwhile, on the other side of the solar system, researchers have also been investigating a certain planet's rings. I'm not talking about Saturn, though, because while Saturn definitely gets all the attention, it isn't the only planet we have with rings. All the gas giants have them. They're just not as impressive. Still, that doesn't mean they aren't special, because last week, scientists announced that they've gotten a better glimpse at Uranus's rings, and butt jokes aside, they're pretty interesting. The first of these rings was officially discovered in 1977. Now, scientists think there are 13 of them, and many are rather uncreatively named after letters in the Greek alphabet. The brightest one is Epsilon, but that's not saying too much considering it's about as reflective as charcoal. But it turns out that it's unique among all the rings around other bodies in the solar system because it's missing all of its dust-sized particles. They're all roughly centimeter to meter sized. Scientists have suspected this before, but now 2 teams of astronomers have confirmed it, and their paper has been accepted for publication in the Astronomical Journal. They got their results using Chilean telescopes to study the microwave and mid-infrared light emitted from Uranus's ring system. This was the first time anyone had imaged the rings like this. But as for why there's no dust in the ring, We still don't know. There's certainly dust elsewhere around Uranus, so maybe some gravitational entity is kicking the dust out of the epsilon ring, or another is making it clump together. Because it's a unique system amongst our gas giants, it's definitely worth investigating, especially since we can't even tell exactly what the rings are made out of yet. Besides looking at dust, the astronomers also produced the first temperature measurements of Uranus's rings, and they're only about 77 Kelvin or so, which for reference is the temperature liquid nitrogen boils. That's really cold, but it was actually higher than expected, and it could suggest that particles in the ring rotate slower than models suggest. If they do, the side facing the sun would get to absorb more radiation, and the side away would have more time to lose its heat. The team hopes to continue studying Uranus when the James Webb Space Telescope eventually launches, which will potentially happen in 2021. It will have a suite of instruments sensitive enough and at the right wavelengths to finally determine exactly what the rings are made of. So not all research about the solar system is going to help us directly on Earth. Sometimes we're just curious, but that's an important part of being human, and we here at SciShow Space are totally here for it. Speaking of being curious, this episode is brought to you by our patrons on Patreon. Thank you for your support and for being such a thoughtful and curious bunch of people. And special thanks to Dan Nillette, who is this episode's president of space. If you want to learn more about supporting SciShow and how you could become the next president of space, you can head over to patreon.com/SciShow.